turn off your, okay, just turn off your video or sound. During the presentation, the video and sound will be disabled, but we'll enable both of those features during the Q&A session. And if you don't want your voice and you have a question, just pop it into the question down at the question and answer box. Now, let me introduce myself again. So as I mentioned, I work at the Los Angeles Public Library in Los Angeles. Our building is in the south of Pico Boulevard on Robertson Boulevard. We are a neighborhood science branch, which means we have the neighborhood science kits that you see on the screen there. And that strange building above that, that's actually my library. So come and visit me sometime. If today's program inspires you to become a more active partner, not just with this citizen science project, but interested in other ones, please come by. We have the kits available. We have lots of information. You can go to our webpage. It's a lot out there. We also love to hear from you about the kind of materials, the programs and services you'd like to see. And I think next, okay, now on to our NeiSci Tuesdays. NeiSci, in case you're wondering, is short for neighborhood science. Neighborhood science is known by many names. It's commonly known as citizen science. It could be also community science, crowdsourced science, contributory science, or even street science. It's basically research that's conducted by non-scientists and non-professionals or ordinary people like me and you. You don't need to be an A student in science or math, which is a good thing for me. You don't have to have a science background or degree. All you need is curiosity about the world around you. These NeiSci Tuesdays is a weekly program series about learning and contributing to science and sustainable practices in and for your neighborhood. Now, this NeiSci Tuesday program series runs from March 22nd through April 26th. So if you enjoy our program today, don't forget to check out and register for the upcoming programs at the address you see up there, lapl.org/NeiSci Tuesdays. And then if you can also register by scanning the QR code or going to the short link that you see on your screen. And we'll give you those links later on at the end of the session also. So today's program is about water in our homes, brought to you by the Crowd the Tap project team. We are joined by guest speakers who will share with us very important information about lead contamination in our water and its impact on our health. They will also share with us a quick and easy neighborhood science or citizen science project you can participate that will help you identify the piping materials used in our home. First, our first guest is Karen Cooper. Dr. Cooper is an associate professor of forestry and environmental resources at North Carolina State University. She's also the founder of the citizen science project Crowd the Tap. Dr. Cooper is an advocate of participatory science practices, including public science, citizen science, and community science. She pursues scholarly inquiry into these areas with a lens for justice, equity, diversity, and exclusion. JEDI. She is dedicated to training and mentoring students to become public scientists so they can pursue careers and weave science into the fabric of society. We also have, let's see. Okay. We also have Emma Zawoski. Emma is the manager of the sorry. It's a little informal, so sometimes my tongue gets a little trips. All right. Emma is the manager of the Crowd the Tap project. She's currently pursuing her master's degree in climate change in society at North Carolina State University. She enjoys kayaking and recently became entirely fascinated with birds. Emma, I think you're going to want to watch the NeiSci Tuesday next week too. Anyways, let's get started. I'm going to stop sharing.
Okay, great. Thank you. Thank you for having us here. I'll elaborate a little bit on the introductions. Also, because actually, so my background is actually in ornithology. So I'm really excited that Emma's into birds now. And yeah, here at NC State, we usually call it public science, what we'll be talking about today. But I love the name neighborhood science that you all use. That's really great. And Emma's been with the project really, I don't know, what is it, like 10 days now or less? I don't know.
Yeah, about a week.
Yeah, she's new and she's learning super fast. Anyway, but so we'll present together. She'll correct me as we go. But also, if you have questions, like we do want to keep this fairly informal. So if you have questions, as we start to cover the project and explain things and talk about it, you can put your questions in the chat, or I think there's a feature where you can raise your hand and the moderator will let us know that there's a question. So anyway, so just keep that in mind. I don't want anyone to get lost, as we're talking about things. So let's see, I'm going to go ahead. Well, actually, let's start with that very first question, which is like there's a Zoom poll feature, which is, it's the H is missing, but anyways, have you heard of the lead and water crisis that happened in 2014 in Flint, Michigan? It started in 2014. So you can say yes, no, or maybe. And yeah, I'm just curious how familiar people are with this event, which honestly, to me, it feels like it was so recently, but really it started back in those pre-pandemic days, like well before. And so I can't see the percent voting, but whenever you think it's ready that people have had enough time, then we can see if people answered. Can we see the results?
Yes.
Oh, here we go. Okay. All right. So half of you all are familiar with the Flint water crisis, and then some maybe, and then some are not. All right, and that's good. That's good for me to know, because for really what happened in Flint, Michigan, was that a change in the source of the water, without it being treated properly, led to an enormous amount of people being exposed to lead in their drinking water. And that really raised a lot of awareness among the federal government, in state governments, in the EPA. It just brought a lot of attention to the fact that there's still issues with lead in water. And I'll talk a little more about that. I'm going to share my screen. Hold on, let's see. I have the right one. And just walk us through this a little bit. So can you all see my screen? Yeah. Okay. So, Crowd the Tap is it's a public science project, participatory project. that investigates and promotes safe drinking water. And just to be clear, that it's a human right to safe drinking water. And everybody, so in the United States, it was in 1974 that there was actually a law passed called the Safe Drinking Water Act. That came shortly after what you might have heard of was the Clean Water Act, right? Now, the Clean Water Act is about like rivers and streams and lakes and natural water bodies, and about those being clean in the sense that they can support wildlife and fish, and all those kinds of things. The Safe Drinking Water Act is specifically about drinking water. So often when we talk about natural water, we talk about it being clean, and that has very specific standards. Like clean water should have a lot of invertebrates in it and a lot of living things in it. That means that it's clean and healthy water for nature. Safe drinking water, when we talk about drinking water, we talk about whether it's safe, and that has very different standards because we don't want things living in it, but it might have other chemicals in it that treat the water. It might have fluoride, it might have chlorine, it might have things to keep the water safe. Anyway, and it's under the Safe Drinking Water Act that there's provisions for lead. Yeah, okay, and so there's a really good question from Gloria that says, if lead is odorless and tasteless, which it is, how do we know if it's in our drinking water, right? In home and all those things. And that is a really great question, because with our senses, like our taste, our smell, sight, even, we cannot detect lead. And at the, well, and I don't want to jump too far ahead, but so like part of what we're doing with Crowd the Tap is to figure out what we can do and figure out where it is. And so part of that is understanding how water systems work. And now some people are on well water, but what I'm going to talk about right now is for people who are on municipal water, which I suspect all of you are. And so with municipal water, there's the water main, there's all this sort of plumbing, I guess, if you will, that's owned and managed by the public utilities. And so there's a water main that is often under roads, and then it connects to a water service line. And often there's a little gooseneck that is the connector piece. In my state, those goosenecks are often lead. I don't know if it's that way everywhere. It's the most malleable kind of piping. And so it's really good as these connector pieces. Anyway, that area is publicly owned portion of the water system. But then once that service line crosses onto private property, like buried underground, but crosses onto private property, it's considered to be under the ownership of whoever owns that property. And it extends into a home, and then is the water and the pipes, distribute through a whole system of pipes within the household. And that's the focus of Crowd the Tap, is this privately owned areas of pipe that are part of households. Because there's a lot of attention and programs out there. The EPA is watching and communicating with and requiring data from the utility companies. Cities are working with utility companies. States often have regulations with utility companies. There's a lot focused on sort of the public side that the utility company manages. And there's talk about replacing those service lines and ensuring that those don't have lead. There's really not as many programs, or any that I really know of, that are very specifically focused on households. There's been more recent efforts to focus on schools, because children are the most vulnerable to lead poisoning, because it can affect brain development. but anyway, but there's just not as much focus on homes, and that's where Crowd the Tap comes in. And one of the things that's often not realized is that the way the laws are written right now, with the lead and copper rule, it's called, is that preventing lead exposure is a shared responsibility between the water providers, the utility companies, and the households. So it's not entirely considered the legal responsibility of the water providers to keep us safe from lead exposures. And the reason is because the utility companies don't own all of the pipes. And so it's, and so I'm just looking at this other really good question. It says, what would be the simplest and least expensive way to make our drinking water safe and lead-free? And what can we do or implement in our homes as citizens without city or government help? Okay, well, so the answer to both of those, I guess, is water filters. So if you have any concerns about whether there might be lead coming through your pipes and in your water, the most immediate action you can take is to get filters that are certified by NSF. It'll say that on there, NSF certified for lead. And they might be filters that can attach to your point of use, like to the faucet itself, or they can be filters that are in a pitcher. And if it's NSF certified to remove lead, then it really will. And it's very effective at eliminating lead from drinking water. They have to be replaced periodically. Filters don't last forever. Anyway, but that's the safest and most immediate. It's not, most don't consider that like the best permanent solution. The best like long-term goal is to remove all the lead that's in our plumbing. Because I guess, I don't know if I said this, but really the only source of lead comes from the pipes themselves, right? So it's not like other contaminants, like in North Carolina, we have a problem with PFAS chemicals, that were released by industry into our waterways and into our groundwater, and then it's in our drinking water. It's not the case like that. In this case with lead, it really is from the infrastructure itself. And so I guess with that, actually, let's go to question 2 for the Zoom poll. Okay, so have you heard of President Biden's new infrastructure bill? And so again, you can answer yes or no or maybe. And when I started this project, I was told that a lot of people aren't familiar with the word infrastructure or might not know what is meant by that. And so now I was like, okay, well, now there's an infrastructure bill. So I think people know what it means. I mean, there's a lot of types of infrastructure, but okay. Well, I don't know if we have enough votes to in yet to see that. Let's see. Okay, so similar to before, so it's kind of split between yeses and nos and maybes. And so yeah, replacing leaded infrastructure has become a national priority. It became a national priority shortly after the Flint water crisis. And the infrastructure bill that Biden was pushing through is dedicating really billions to replacing infrastructure, including lead pipes. This is actually an old tweet that he had, but it says, every single American has the right to clean drinking water. It's just plain wrong that in the United States of America today, millions of children still receive their water through lead service pipes. It's long past time we fix that. And it'll run again. It says as many as 10 million homes still receive drinking water through lead pipes. Actually, so let's, oh yeah. So while this plays, actually, let's go to the next Zoom poll because I want to see how people are feeling about this. So on a scale of 1 to 5, with 1 being not really very worried and 5 being very worried, how concerned are you about lead in your water? And I know some of you aren't in the United States who are attending, and I don't have statistics about infrastructure in other countries. So I'm just going to be talking about the US, but these infrastructure issues, I think, are global. Okay. Let's see how concerned. Okay, so half of you are very concerned at the max at 5, level 5, 30% almost at level 4, and then a few, and there's really no one who's not at least a little bit concerned. So first well, it's a balance. I'll set your mind at ease a little bit in some ways, because 10 million homes is a lot of people to be concerned about. But also it's about 1% of the US population, of the US households, that actually probably still have leaded infrastructure. So in many ways, the problem that we're facing in wanting to fix this is like finding a needles in the haystack, right? So locating the lead pipes that are out there, because even though there's 10 million like lead service lines or more, probably, it's just, we actually don't know where they are. And so on the one hand, if you were playing the odds, we're all sort of at low risk. But we do know also that with many water quality issues, other studies have found that certain segments of the population tend to be more vulnerable to water quality issues than others. And that tends to be environmental justice type issues. So it tends to be marginalized communities of color and low income communities still tend to bear the brunt of repeated water violations by utilities and other sources of contaminants. And we're trying to investigate if that's also the case with leaded infrastructure. And so the reason it's a big mystery is that like most of the lead pipe infrastructure was buried underground well before the EPA banned the use of lead. So lead pipes were banned in 1986. And actually lead in our faucets, that really wasn't banned until 2014. That law didn't go into effect. And so, but in terms of the pipes that are buried underground, so much of our infrastructure was put into place before 1986. And if you think back in time, I don't know how old people are on this, but that was before computers were really widespread. Most information and records was just on paper. There wasn't the internet. We didn't have digital records like we have today. And so there really wasn't good record keeping. And so literally we just don't know where all these lead pipes are. A lot of cities and different places and municipalities are doing inventories of the utility side. We're trying to do an inventory of what's in homes. Where are there hot spots in, what neighborhoods might be hot spots? Where do we need to turn attention? For this infrastructure money for replacements, where does it need to be directed? Which communities have these problems? That's what we're trying to find out. So a little bit more on lead pipes. So if you have, I guess, so the question is, some people might wonder, if I have lead pipes, does it mean I have lead in water? And it actually is not, it doesn't always mean that you have lead in water. So even though the project focuses on pipes, because that's what we want to have eventually get replaced, it doesn't mean you're in immediate danger. right? Like in Flint, Michigan, there were lead pipes there for a very long time. It wasn't until the water wasn't being treated properly that the pipes started to corrode and release the lead. So what these figures shows, this one on the left is showing a lead pipe that the municipal water is treating with these phosphates that that change the pH. I think they elevate the pH so that lead does not leach out of the pipe. On the right, it's showing a system where the pH of the water is corrosive, and so water is leaching out. I mean, lead is leaching out from the pipe, from solder at the joints, all kinds of things like that. So anyway, this is another reason why that if we suspect we have lead pipes in our home, it can be really important to let your utility company know so that they know they need to treat the water and make sure it's not corrosive. All right. Okay, so if you think you have lead pipes, if you worry about having lead, how can you know if it's present? And this is really tough because laboratory tests can be really expensive. And at-home tests are actually not accurate. Ones that you can buy on the internet and do at home for testing lead at the moment are not entirely accurate. And so that's the other role that Crowd the Tap is playing. So what we're trying, the way we've set up this project is that if people share data through our survey, and it's information about the age of the home and the types of pipes, other aspects of the water, including some aspects of the chemistry of the water, like the pH, the alkalinity. We've been working on developing a model, it's not quite done, that helps predict the level of risk for your household. If it's high risk or if it's low risk. If your household is high risk, then we have some water tests that we can send you for sending water to the lab. And then also, we're trying to improve the types of kits where you can test your water at home. And we can send those with sort of a modified, like a hack of the different instructions to see if that can be a test that starts to work. So I'll explain a little bit more about that with Crowd the Tap. And so this I'm basically going to walk through, actually, I'm going to switch tabs for a second. This is the Crowd the Tap website on SciStarter. And if you visit it, there's 4 different videos. The first one, this is Amani Bell. She was the first graduate student on the project. She's finished. She gives, she gives an introductory video, just an overview of the project. And then there's some how-to videos by Brian Mallow, the science comedian. He's my neighbor, actually. And he gives one that is about how to find your pipes. He goes into his cellar. He shows how he found his pipes, and then he shows how to enter data online. Then he has another video, this one, which we're going to go walk through today a little bit, about how to measure your water chemistry for Crowd the Tap. And then he has a final one, if you rank high and you get a kit from us, on how you collect the water to send to the lab. So those are the different parts of Crowd the Tap. It makes it seem kind of complex, but we're going to just start sort of simple. But anyway, I also wanted to point out for teachers, if there's any teachers on or watching the video, that we do have a lesson plan. You can sign up for our, well, you can download the lesson plans. We have one for advanced placement environmental science teachers. These are high school teachers who teach AP environmental science. It's a great lesson plan. And then we also have one for chemistry teachers. And then we also, well, there's a Spanish translation just for our website that's here. And then this Qualtrics form goes, if you want to sign up, let us know if you're a teacher and you're using Crowd the Tap lessons. You can sign up through the form so we can send you the supplies that you'll need to have your students do this with their families. Anyway, and then there's also this page of Crowd the Tap at About. which has just other information about Crowd the Tap. Anyway, and it's from there, actually. If you go down here, see our story, that's the tab that I'm on right now. So you can always come back to this sort of slides that I'm showing you. They're up on the website. Emma, if you want to put the crowdthetap.org/about in the chat, then people will have that one too. Anyway, but so this is sort of what the Crowd the Tap looks like. There's, oh wait, actually, let me go back to that. So if you go here to report data, there's 3 tabs here: Crowd the Tap, that's the basics, report data, and then connect. I'm going to visit connect real quick, which is basically a forum where you can post comments and respond to people. It's for, like, if you are facing problems with lead, you can try to reach out to other people and maybe work together. So it's meant to be sort of a community building area. But the main part of Crowd the Tap is this one called Report Data. And there are these 5 tabs that each are like a survey where it's like a questionnaire. And it's your consent. It's a consent page, like consenting to be part of the research. I'll review that in a minute. Your home, it's about your home, your household demographics, household, like the house itself, its age, and all those kind of things. There's questions about your pipes, your water. I'll go into that in a minute, and then your water chemistry. So this is a little bit, it's on this site too. So the consent page is really long. It's going to look like, what in the world? Why, what is all this legalese? It's there because it's because our project involves studies of your household. It's considered, like, I guess, human subjects research. It's just good research practice to make sure that we've fully informed you of what's happening with your data. And this consent page is where that happens. And there's a lot of aspects on this page. If you are 18 or over, you can consent to participate in the project and to share information with us. If you're between the ages of 13 and 17, you can participate in the project, but only with parental consent. And there's a place on the consent form for your parents to provide their name and email as giving their consent. And so that's what teachers use. There's also a place on the consent page where you can list your ambassador. Now, you might list your library, because your library is your ambassador. Or if you were, for example, a teacher and your students were doing this, they would list you as the teacher, as the ambassador. And what that means is, it's simply, all it really does, it lets us tell the ambassador how many of the people they reached participated in the project. So, like, if you were a teacher and you assigned the project to 30 students, we don't share the data with you because all the data is confidential. Let me rephrase. There is an anonymized data source that everyone can use, but we don't share the names of students who participate, but unless the students give permission by saying, share that with my ambassador. I don't know if I made that totally clear. Let me go back to this tab to show you something else. All of our data are right here. So on this tab on scistarter.org, crowdthetap.org, it'll redirect you. You can download all of the Crowd the Tap data anonymized. So it doesn't have people's home address. It doesn't have their names. It's just been completely anonymized. It has city and state, and then all the details that are related to that household. And so you're welcome to explore the data yourself, or use it in a classroom setting or anything like that. Oh, am I missing questions? Sorry, I wasn't monitoring the chat. Okay. Okay, so we don't have anything for elementary educators. They're all at the moment geared toward high schoolers, and middle schoolers have used them. And it's because of that cutoff at age 13. I think, I mean, it's probably worth looking, if you teach younger students, to look at those lesson plans and see what you can adapt, and then see what might be appropriate for students to do with their parents, to do the project with their parents. Okay. So now there's one other part of the consent page. Like I said, it's super long. There's the personal consent, the parental consent, there's the consent to share with the ambassador. And then there's a part at the bottom where people can consent to share with their utility company if they want us to share the data non-anonymized with the utilities. It's your choice. The default is that we won't share it. If they want us to share it with the EPA, and then if they want us to share it just with other people who are advocating for lead service line replacements and need to know where they are. But anyway, it's all optional. Anyway, after consent and you decide sort of how you want your data used, we try to give you as much control of your data as possible. Then there's this tab about your home. It's like, what type of home? We ask if you pay the water bill or not. That tells us basically if you're on a private well or not. If you're on municipal water, when we ask about pipes, we ask about your home pipes and your service line. If you're on well water, we ask about your well casing and your home plumbing. Anyway, so there's a bunch about your home and your household. And so I'll mention that for a second too. We do ask about race and ethnicity and income. On all of those questions, there's an option to say, I prefer not to answer. And we prefer if you choose any option, even if it's prefer not to answer, rather than just skip it, just so we know you saw the question and you selected whatever you wanted. The reason we ask those questions is because, as I alluded to earlier, we know for other water characteristics and other water violations that there are certain segments of our society that are just more likely to get hit with those health disparities. And we want to know if that's happening with lead in water. And so rather than overlay the data on census maps and look at it that way, we just want to know for every household, if we can, what those demographic characteristics are, and do those households have a different level of risk. But again, you can opt to not share. You can opt to not disclose some of that information if you want. Then the next tab is about your pipes. And like I said, we ask about the service line. That's what goes into your home. Brian has a great video on how to find it. And usually if you can find your water heater, you can, it really varies from house to house. If you own the home, your inspector might have said what the service line is. You can call your utility and they might know. Anyway, and then we ask about the home plumbing, and you might have many types. Oh, I'm on the right thing. You might have many types of different types of piping in any given home, but we basically categorize it into either being lead, galvanized steel, copper, or plastic, or other. And there can be a lot of types of pipes. One thing I wanted to mention was that a lot of times when people look for pipes, sometimes they just go to their kitchen sink, they open up below the cupboard below the sink, and you're going to see a big old pipe there, and it might be plastic, it might be metal, and it's going to be funky shaped. But just remember there's lots of really big pipes that take wastewater away from your home. And those can be completely different material than the water that's coming into your house with the drinking water. And the drinking water pipes are really, really narrow. They're like 1/2-inch pipes, maybe 3/4 inch. And they're really narrow like that to keep the water pressure maintained. And so anyway, so don't be fooled by some of those big pipes that are taking wastewater away. That's not what you're looking for. You're looking for the really skinny pipes. And we have information in our videos on how to tell the difference between steel and lead and copper. But another thing that I want to caution you about is that it isn't just lead pipes that have lead. Steel pipes sometimes were lined with lead. They had a lead lining, and there's no way to know if your steel pipe has lead lining or not. So even steel means you might have some risk. Copper pipes were often soldered together at the joints with lead solder, and that can chip off into the water. And so even copper pipes can sometimes pose a risk of lead exposure. So it isn't as simple as I have lead or not. It can be really, it's just really tricky, is the bottom line. After your pipes, we ask about your water, and we have just a series of questions about how does your water taste? How does it smell? How does it look? There's always an other, or like it's clear or whatever. Now, none of these, like we've talked about already, we cannot see lead, we can't taste it, we can't smell it. But some of these characteristics are correlated or like sometimes associated with what might indicate a higher likelihood of lead. So for instance, if your water was rusty colored or staining, it might mean it's fairly corrosive to the pipes. And so that if you did have lead pipes or lead solder, it might be a problem. And also we wanted these observations really just to see about people's perception of their water quality and if that might vary with other household characteristics. Finally, there's this last tab, which is probably the most confusing, which is about your water chemistry. And this is the one for which we send water. We send these, your library should have these sort of little brochures and kits with these, I can't do this backwards, these color charts for measuring your water chemistry. And so these come in a little bottle, and they're these really simple strips. Now, what I'm going to say is the most confusing thing is that they have a lot of different elements that they measure. And the kit itself says it measures lead. I want you to just completely ignore it because it's really not a very good test of lead. What we like about this is that it gives us an estimate of pH and alkalinity and some of the other aspects of water quality that help improve our model, that are sort of like with the other like visuals with water that are can be somewhat indicative of what's happening in your water system. Yeah, and you can pick up these water strips. Well, there, it's in the chat. We're going to demo. I don't know. I hope we're not running out of time. There is a video. Our plan was, I've been so long-winded today. It's not really like me usually to be this way, but we were going to demo it. How are we on time? Do we have time to demo this?
Yes, you do. You have about, well, the program ends at 5:15. So. Oh,
okay. Yeah. And so I think we can demo it and still have time for questions. But what I'm going to say, we'll go back to the demo. I'll just say, based on all the information that you give us, with our rudimentary model, we can send results that basically say whether you have a low risk or a high risk. But the models, like I said, right now, if it's low, 9 out of 10 times, that's correct, which is it's not terrible. But if it's high, the model's really not, it's not very accurate right now. So there would be no need to panic because it's only right 1 out of 3 times. So, but what we're using that as is a way to say, but let's test your water and let's find out. And that's how we're prioritizing our actual lead testing. Like, so not the chemistry strips, that's just water chemistry. But if there's reason to believe that you're high risk, we can accommodate some testing of your water in a lab to see if there's lead. And we also have, where are they? These this is our water safe kit. This is a little kit that you can buy on the internet and test your water at home. Now here's the thing with these. They're not completely accurate. And here's why. Lead in water comes in two forms. It can be dissolved lead, meaning it's just like, it's completely dissolved in the water. Or if it chips off from solder or whatnot, it can still be in a particulate form, like little chunks. We can't see it, it's still microscopic. This kit can test very accurately for dissolved lead, but it can't tell if there's particulate lead. So what we're testing, and what has worked in the lab, but we don't know if it works yet in all water systems, is that if you add some lemon juice or some vinegar to your water sample and let it sit long enough, it'll digest the lead, the particulate lead, if it's present, and turn it into dissolved lead. And then you have a sample that's all dissolved lead, if it's present at all. And then this kit could work at home. And that'd be a real game changer for people to be able to test their water at home and know whether they have, and accurately know whether they have lead or not. But we're still testing this. We've been working with high school environmental science classes across the country, different water systems, and trying to see. And we're still not 100% sure that it works, but I just wanted to give you that little preview. But for now, what we're relying on is pipes and our model and looking at your water chemistry. And so, okay, let's run through this. So if you get a water, let me pull this water chemistry strip out. And I'm gonna move my camera. And Emma, if you wanna, it's all I can do to concentrate on. For some reason, it's like backwards and it's really hard for me to center this. So.
Yes, I can jump in here with some explanation if you would like.
Yes, and I'll try to get this visually correct. But this is the strip that you would put in water, right? You put it in a glass.
Yeah, and you would have to make sure that the glass is tall enough so that each one of the colored squares can be submerged when you put the stick in the water. And then, okay, I'll explain it. So basically you would have to, like I said, fill up the cup, make sure all the colored squares are in there in the water, and then you let it sit in the water for 5 seconds. And then you take it out, place it on the table. Do not shake the stick at all, the test strip. Don't shake it. You don't want the water to be able to sit on there. And you're going to let it sit for a minute. All right. And during that minute, you can just kind of hang out. You can have a little timer on your phone to make sure that you know that a minute's passing. And then you place it right where Karen has it placed, right in that black square.
Right, it's so hard to get this.
Yeah. Yes.
And my
Right.
shadow.
Black square.
Sorry. Yeah. Can you see it even? I hope you can see it.
Yeah. Can you twist your camera to a different angle so it's like straight instead of, yes.
Let me try this.
That way.
Is that a little better?
It's flipped. Maybe just go like a 90-degree turn.
Oh, is my, oh, I see what you're saying.
Yeah.
Oh, here, you know what? I have a better solution. Okay. Oh, well, I want everybody to see the whole thing. Okay, hold on. Okay, is that better?
That's clear, yes. That's
Okay.
clear. Can everybody see that okay? Is that clear enough for everybody?
So I would put my name here because I'm going to photograph it. So I would, I don't know if I can do this. I would get my camera setting and I would, now I'm doubling, and I would get it so my camera can take a picture of as flat as possible, better than what I'm doing now, of the color strip with the color chart. And then I would take a picture. And there's a place on the website to upload that picture in the data entry with your chemistry.
And then so I don't know if you guys can see it super clearly, but above the colors, like the longer squares of colors on the side, there's numbers 1 through 7. And those numbers are going to correspond to whatever shade your particular test strip came out to be. So yeah, you would do what Karen's doing, just kind of slide it around to see which color matches the one on your strip. And whenever you get a match, you would write that number. So let's just say this one looks closest to 1. We haven't tested this strip yet. But
Yeah,
if it's a 1, yeah, if it's a 1, you would put a 1 in that little white box to the far right. Yes, right there.
And I forgot my pen. But
Yeah. And then just do the same for each one all the way down the line of those white boxes.
And then I'll open this up.
All right. And then you would take the number that you wrote in the little white box, and you would look over to this water chemistry table side, and you would find the column that has the number, so 1, and then you scroll down, and it says alkalinity ppm, and then you circle that 0, because that's the, as you just asked in the question or in the chat, is there a key? That is the key right there. So the 1 that you got on the colors, that means that there's 0 alkalinity ppm, basically.
Yeah, and you go through and you do it with each one. And then these are what you enter online. There's a drop-down menu on the chemistry set, on the tab on that. Okay. Sorry. I forgot my water and my pen, but yeah, okay. So, and it's not necessarily that there's safe colors or bad colors. They're all just different. And they're all going to indicate different things related to, like I said, none of them are like definitive or like, oh, that means you have lead or that means you have a problem. They just help us narrow in. They just provide a little bit more information for us to make sense of your water system. In some ways, it helps us make sense as to what your utility is doing and how they're handling and managing the drinking water that's delivered to your house. So, and then, like I said, the model results and that. And in addition, so the way the project is structured to distribute, like anyone can write us and we can send this, this brochure with the chemistry strip. But what we prefer to do is to work with our ambassadors, like the librarians, like our teachers, but then we also do have community leaders who just are concerned, people who are concerned about their neighborhood, and that can also function as ambassadors and receive a whole bunch of chemistry strips and brochures and work with their neighborhood to participate and crowd the tap and find out if they're a hot spot or not, basically. So there's lots of ways to be involved. And I think with that, we'll take questions or have, any further discussion that you want to have. I'll stop sharing my screen.
Okay, Karen, I think you have been answering the question all along, and I haven't seen any new questions, but if any one of you have any questions relating to the testing or to the presentation itself, please, or the content, please feel free to put them in the chat and we'll just have Dr. Cooper here answer for us.
And also, I mean, if people have questions about public science, neighborhood science, any of those things, citizen science, I'm happy to answer those questions too. That's been one of my areas of interest.
Hey, we got one question from Gloria. Using the strips to test the water, what level of accuracy do the strips have?
Yeah, that's a good question. They're pretty coarse. Well, I mean, I think for some of the features, like I said, for lead, not accurate. And I'm not sure for some of the other things, but the alkalinity and the pH are two of the ones that I know seem to be important, like for the predictive model. Yeah, and so, but I wouldn't hold the other elements to be that, yeah, to be that accurate. Why do we need a penny and a magnet? Okay, yeah, that's a good question. So for people who don't know what type of pipes are in their house, like let's say, you haven't had a plumber there, or you don't, maybe you rent and you don't, so you don't have records of its construction or anything like that, and you're going to go and try to figure out what the pipe is made of. The most definitive way is to use a penny and a magnet. And what we'd say is that, well, if you use the magnet, it will stick. If it sticks, then it's a steel pipe. And so if it doesn't stick, it's one of the other types of pipes. Let's put it that way. So usually you can tell a copper pipe because if you scrape it, it's going to be the same color as the penny, right? A copper penny. So it just sort of helps you with that. If you, and you can usually tell plastic. Sometimes pipes are painted, sometimes they're have like a lot of discoloration. So sometimes it can be really hard to know like what the material is. If it looks though like it's like classic like metal, and usually that's what it boils down to. It's like someone has metal, they're like, is it lead or is it steel? And so if a magnet will stick to it, it is a steel pipe. If it doesn't stick to it and you want to really try to know for sure if it's lead, then what we recommend is that that you wear your mask and potentially gloves, and you use a penny and you scrape it. And lead is actually like a fairly malleable, soft metal. And so when you scrape it, it will produce like, it'll kind of come off a little bit and it'll produce a really like a sheen, a real shiny streak. If that happens, we recommend you use like a wet paper towel, that you clean that area, that you clean anything that you were working with. And like I said, wear a mask, be sure you don't inhale it. Anyway, and so that's basically the penny and magnet are like sort of standard ways of like differentiating different types of pipes. And actually, I will say, just going back to the person that was asking about elementary school lessons, I should post this on our website. We did a session with Science Friday once, and they had a great little lesson with different types of materials, like just household stuff that was like different. Some was plastic, some was metal, different types of metal, whatever. And it was using a penny and a magnet to like figure out what it was. And it was a great activity for little kids. Anyway, I didn't mean to digress there. Yeah, and where am I now? Okay, the strips of the test water. Yeah, I mean, and the elementary school students could use those test strips, just to learn about some of the basics about water chemistry. Yeah, cast iron and galvanized steel, I think yeah, and will it stick to it? Yeah, because I think they have the similar elements in them. Is that what you're asking? I think that, will a magnet, I'm gonna go test it when I went down in my kitchen. I think will a magnet stick to cast iron? Is that what you're asking? I'm going to test that. I think it will. Is there a particular location of the pipe that I should do the test on that will give me an accurate read, like the one under my sink or wherever? Yeah, and that's a good question. And so it can be the pipe anywhere. Well, the service line you're going to want right where it comes into your home, which might be, well, it could, I'm not sure where, I mean, it really varies with the style of the home. But yeah, it could be, and I think finding your water heater and then the pipes that disperse from your water heater throughout your home sometimes is easier than getting under the sink and trying to get the water that's coming into your faucet, right? Because there's usually just all the big pipes that are taking the water away. And so, yeah, usually we recommend that you go to where your water heater is. And then some of the pipes around there are the ones that you can test. Oh, okay. Yeah, thanks, Aya.
Okay, it looks like we have all the questions answered. And so I'm going to turn this back to our host. Dr. Cooper, do you have anything else to add before I turn it back to Anna Marie?
No, thank you all for coming. And you can, Emma, if you want to put our email, the Crowd the Tap at NCSU in the chat, we'll put our email in the chat in case you have questions or want to follow up on anything.
Awesome. All right, Anna Marie, was going to hand it back to you. We already did the Q&A, so we can skip this one. Just flow right through.
Sorry, I had to unmute myself. Okay. Let me go to the next one. I do want to thank you, Dr. Karen and Emma. That was really fascinating. And I know I'm going to go home and start poking around under the sinks, looking at my pipes. Okay, let's see. Okay, it's, well, okay, I certainly found this program useful. I hope the people everybody else was able to find it helpful. And it's really great to learn new things that'll help our neighborhood and help our environment and make us all very more resilient to all those issues that are out there. Our next NeiSci Tuesdays, which is, it's going to be March 29th, is going to be our LA Birders program. So we'll be learning from the Los Angeles Birders students about LA's amazing biodiversity, where and how to find local birds in LA area, where to find them. Most importantly, you'll learn a new tool to help identify those cool birds and wildlife that you've observed. And with the great weather out right now in spring, it's a great time to start looking for birds. If you haven't registered for the event, be sure to do. You do. Again, we're gonna put the QR code in the chat. You can always go to our website, lapl.org, look under the STEAM. And before you leave the program today, we do have one more question for you. Please let us know one thing you learned today from today's program. You could just type it in a chat. Again, I want to thank Dr. Cooper and Emma for sharing all this information with us. And I want to thank everybody who came and listened to everything. Again, if you learned, put in the chat, if you learned one thing, one of the things you learned today, please put it in the chat. We hope to see you again at one of our next NeiSci Tuesday programs. Next one is at March 29th at 4 p.m. Thank you.